Energy of an electron in the nth orbit, Bohr model. In Bohr's atomic model, electrons revolve around the nucleus in a fixed circular orbits. Each orbit has a definite energy. Each orbit has a definite energy which depends on its distance from the nucleus. The energy of an electron is quantized, meaning it can have only certain allowed values and not anything in between. The energy of an electron is quantized, meaning it can only have certain allowed values and not anything in between. Understanding the energy of an electron in the nth orbit helps us explain the stability of the atom, spectral lines of hydrogen, and energy transition when an electron jumps from one orbit to another. Understanding the energy of an electron in the nth orbit helps us explain the stability of the atom, spectral lines of hydrogen, and energy transition when an electron jumps from one orbit to another. This forms the basis for modern atomic physics and is very important for NEET. Potential energy. Electrostatic force between nucleus which has a charge plus Ze and an electron which has a charge minus E is conservative. Potential energy in the nth orbit is given by a formula epsilon n equals minus 1 upon 4 pi epsilon naught Ze square divided by Rn. The value of Rn, the radius of nth orbit, is Rn equals epsilon naught h square divided by pi m E square multiply n square divided by Z. Let us substitute this Rn value in potential energy term. So, epsilon n equals minus 1 upon 4 pi epsilon naught Ze square divided by, instead of Rn, let us bring epsilon naught h square divided by pi m E square multiply n square divided by Z. Good. So, the same term has been rewritten as epsilon n equals minus 1 upon 4 pi epsilon naught. Let us bring pi m E square Z to the numerator. Multiply Z square. Then we have epsilon naught h square n square in the denominator. When we simplify this, 1 pi is getting cancelled. Then we have m e power 4 Z square divided by 4 epsilon naught square h square and n square. So the term is epsilon n equals minus m e power 4 divided by 4 times epsilon naught square h square multiply Z square divided by n square. Let us write it here in the corner for further reference. Epsilon n equals minus m e power 4 divided by 4 times epsilon naught square h square multiply Z square divided by n square. Now let us find the kinetic energy of the electron. Kinetic energy in the nth orbit, the kinetic energy of the electron in the nth orbit, Ken equals half times m Vn square. We know the velocity of the electron Vn equals E square divided by 2 epsilon naught h multiply Z by n. So let us bring this Vn to kinetic energy term. Ken equals 1 half m. Instead of Vn square, we bring E square divided by 2 epsilon naught h multiply Z by n the whole square. Let us square each term in the bracket. So we get Ken equals 1 half m e power 4 Z square divided by 4 epsilon naught square h square and n square. Let us simplify this term. So we get Ken equals m e power 4 divided by 8 epsilon naught square h square multiply within bracket z square divided by n square. Let us bring it for future reference. So kinetic energy Ken equals m e power 4 divided by 8 epsilon naught square h square multiply z square divided by n square. Good. Relation between the potential energy and kinetic energy. So look at this kinetic energy. When we multiply -2 with the kinetic energy, we get the potential energy. So the simple relation is epsilon n equals -2 times the kinetic energy. Epsilon n equals -2 times kinetic energy. So let us go for the total energy of the electron in the nth orbit, which is the sum of the kinetic energy and potential energy of the electron in the nth orbit. So let us bring the kinetic energy term and potential energy term to the picture. So En equals Ken as it is minus, instead of epsilon n, let us bring -2 Ken here. So we get the energy En equals minus Ken. Let us have this. En equals minus Ken. En equals minus m e power 4 divided by 8 epsilon naught square h square multiply z square divided by n square. This term we have it separately. The total energy of the electron in the nth orbit En equals minus m e power 4 divided by 8 epsilon naught square h square multiply z square divided by n square. For hydrogen atom, Z equals 1. The atomic number Z equals 1. Therefore, in the place of Z, we have to substitute 1 and we rewrite the formula En equals minus m e power 4 divided by 8 epsilon naught square h square multiply 1 upon n square joule. En equals minus 13.6 multiply 1 upon n square electron volt. Here we substituted the value of m, e, epsilon naught, h, all the values and convert from joule to electron volt. We get a formula En equals minus 13.6 divided by n square electron volt. This is a very important formula in solving problem. Let us go for the energy state. N equals 1. The first energy state, we call it as ground state, where the energy is E1 equals minus 13.6 electron volt. N equal to 2. It is the second state, the first excited state. The energy here is E2 equals minus 3.4 electron volt. When N equal to 3, it represents third orbit. It is the second excited state. The energy is E3 equals minus 1.51 electron volt. And the fourth orbit, this is called third excited state. The energy in the fourth orbit E4 equals minus 0.85 electron volt. Similarly, for N equals 5. As we go higher, the energy states are getting closer and we get finally the infinite energy state. The energy here is 0. The energy is increasing in the upward direction. They become less and less negative. That means its energy increases. Key points. Closest orbit, n equals 1, that's the ground state, has the lowest energy called ground state. Higher orbits, where n equals 2, 3 and etc. have less negative energy. That means electron is less tightly bound to nucleus. Then energy difference between levels decreases for higher n. Rydberg's energy. 1 Rydberg unit equals ground state energy of hydrogen atom. We know that the ground state energy of hydrogen atom is minus 13.6 electron volt, which is 1 Rydberg unit. Reason for negative sign. At infinite distance, the energy is zero. This means bound electron has negative energy. Bound electron has negative energy. NEET tips. Formula to remember. En equals minus 13.6 divided by n square. This is there in electron volt for hydrogen atom. Quick trick. For ground state, the energy is minus 13.6 electron volt. Divide by n square to get higher levels. MCQ alert. Epsilon n equals minus 2 times KEN. This is the relation between potential energy and kinetic energy. And here the relation between total energy and kinetic energy En equals minus KEN. Concept check. Energy levels get closer as N increases.